Okay, this sheet is page 65. This is the rest of the unit that we're in right now. We will finish the unit this week. We will have a test at the end of the week. This stuff will be on it. And the good news is I will be putting the test on Elastic so we don't run into issues with the questions being complicated, redundant, or using the phrase scaled copy instead of just saying dilation. What I need to do is refresh your memory on what we covered before spring break so you can understand what we are covering right now and how the two of them are different. Before spring break, we covered congruent triangles in particular, right? Where, for instance, let's go with a right triangle because it's easier. You had a 3, 4, 5 right triangle, and then you had another, pretend they're equal, 3, 4, 5 right triangle. We would say that they are congruent, which means they're exact copies, right? Everything about them is the same. Enter today's lesson, where instead of them being congruent, they are what's called similar. So for instance, let's say you have a 3, 4, 5 triangle that is dilated. We're going to say by a scale factor of 2, so it's going to get what? It's dilated by a scale factor of 2, it's going to get bigger. So a 3, 4, 5 times 2 would be a 6, 8, 10. You with me? Okay. Remember the maze? Similar versus congruent?
Yeah.
The only time they are not congruent is if the dilation has occurred, right? Dilations produce similar figures. Similar means it's the same shape, but it's a different size. But if you sat here and compared each side to its corresponding side, you get the same scale factor, right? That's called proportional.
Double it, basically.
Yes. Now, what I want to draw your attention to, this is the new part. Notice the 90-degree angle right here. Notice the 90-degree angle in the dilated one. Did it change? No, it did not change. The same is true for this angle here. In the dilated one, it would have remained the same. This angle here would remain the same. So the new part here is if you take a shape and you dilate it, although the sides are changing in length, the angles are staying the same. Y'all with me? Okay, we did all of that in order to fill in our Flipbook. If you look, there are 4 sections that we're going to talk about. When you open up the flap on the Flipbook, it practices each of those sections based on the location of them, okay? So I want you to direct your attention to the top left. It says, when you have similar figures, you can determine the angles and the sides if you have enough information drawn. So if you look at these 2 triangles right here, are they the same size? No. And if I look at it, it says list the congruent angles. You're going to have to write small. Angle A is clearly congruent to what angle in the small one?
L. Oh, wait.
G.
G. Right?
Yeah.
Angle C is congruent to what? Angle what?
F.
Okay, Okay, and then angle B has no mark at all, so it would be congruent to the angle that also has no mark, which is what? H. The next part says PROP, it has a period, sides. That means proportional sides. They want you to say what side is proportional to what side. Come back over here to this. Do you recall triangle ABC is congruent to triangle DEF? That congruent statement told you exactly what angles were congruent to each other and what sides were congruent, right? Do you remember that? Okay, the same thing is true with similar. But instead of writing a congruent symbol, look at this little squiggly. It's just the top part of the, it's right here. It's just the top. I'm right-handed. Why don't you move close? It stands for similar. This little notation right here stands for similar, okay? And it means the shape is the same. One of them got dilated to form the other one. The angles are congruent. The sides are proportional, okay? Angles are congruent. Sides are proportional. So coming back right here, it says, tell me the proportional sides. Well, if you wanted to, right here, you could write triangle ABC is similar to triangle. Now, if I call that one ABC, what do I have to call the other one? Yeah. Y'all see that? If I label the first one ABC, then I have to label the other one GHF. So now I can list my proportional sides. Instead of using the picture, I can list it using this similarity statement. This is going to be really crowded. Don't write big. So AB is proportional. Notice I said proportional, not equal. Proportional to GH. BC is proportional to HF. CA is proportional to FG. Now, when you set those up, the order that you set them up only matters based on the very first fraction. So, like in this case, I would say this is the big triangle and this is the small triangle. So, if I'm doing the big over the small in the first fraction, then I have to be consistent and do that in the remaining fractions. Okay? All right. Come down, bottom left. You should already know how to do this. This is what we've already been practicing. Here are two shapes, and I'm telling you they are similar, and I'm asking you, find the scale factor. So, triangle ABC is similar to triangle that, let's see. So, can you figure out how you would have to name it? So watch how I named the first one. Watch. I went A, B, C, right? Notice I crossed over. I've got 7.5, 6, and 9. So this is, I always use the phrase small, medium, large. So this is the largest number, this is the medium number, this is the small number. So when I named it ABC, I went medium to small. So when I come over here, if I label small, medium, large, I would have to name it what? GHF. Medium to small. You have to go in the same order or it's wrong. Okay? Now I'm going to take all that writing off because it's kind of crowded. Now if you wanted to, you could come above it and put S, M, L, and then here you can do S, M, L for small, medium, large. To me, that's the easiest way to make sure you don't get it wrong, is labeling small, medium, large. Okay, so we said you have to call it GHF.
Good afternoon. Your bus changes for today. Bus 15 will be 35. Bus 114 will double up on 35. Bus 150 is 61. Bus 107 is 30.
Okay, the question says find the scale factor. We have no idea which shape is the preimage, so when you're finding the scale factor blindly, then you're just comparing two sides together. Order doesn't matter. What does matter is they have to be the same side in terms of like small to small, medium, medium, or large to large. You would not compare the small to the large. So in this case, I just picked small because the numbers are smaller.
The buses that are here and you may be released at the bell are 12, 39, 41, 120.